Hello, pre-algebra students. Mr. Lawrence here, and I'm going to go through your review sheet for you. I'm not going to do every single problem, but I'll do some of them, and we'll talk about them. So right now I'm on the first page. I'm on problem number 2, and it says that 5 minus 2x equals 10, and the instructions are to solve for x and show all work. Well, I need to get the x alone, and I see there's a 2 attached by multiplication, actually a negative 2 attached by multiplication, and a positive 5 attached by addition. So to get rid of that negative, to get x alone, the first thing I'm going to do is I'm going to get rid of that positive 5. How am I going to do that? Well, I'm going to subtract 5, of course. But if I do it to one side, I have to do it to the other. So I'm going to get negative 2x equals 5. And now I need to divide by negative 2. And then you could tell me that x equals negative 5 over 2. Or you could tell me negative 2.5. Or even you could have said x equals negative 2 5/10, like that. Okay, pretty simple. Now if you checked your answer, you could plug negative 2.5 in here, multiply it by negative 2, and then add 5 to it. And if you get 10, you did it right. I'm not going to do all that. I just showed you how you can do that really quickly. All right, number 3, negative 7 plus x over 3 equals 1. Well, I'm going to add 7 to both sides. And then I'm going to get x over 3. That's going to equal 8. Now, how is the 3 attached to the x? By division. So therefore, I'm going to multiply. Multiply this side by 3, and I'll multiply the right-hand side by 3. And when I do that, I'm going to get x equals 24. And there you go. Now, for 4 through 6, it says to solve for y. I'm going to circle the y so the two variables don't confuse me. This problem is actually just the same as problem number 2 that we did. I had a 5 minus a 2x. Well, here I have a 2x minus a 3y. There I subtracted the 5. Here I'm going to subtract 2x. I'm going to get negative 3y equals negative 2x plus 6. Now I know Alexis would rather write 6 minus 2x, but I'm going to write negative 2x plus 6. It's okay. Neither one of us is wrong. All right. Now, the y is still not alone. There's a negative 3 by it. And this is where I'm going to divide by negative 3. Remember that when I do it to both sides for multiplication or division, I have to do to all 3 terms. That's like the seesaw example I used with Raymond and his family, right? Okay, so the negative 3 is going to cancel. I'm going to get y is going to equal 2/3 x minus 2. Okay, and there we go. All right, number 8. Number 8 is a graphing problem. I need to get y alone and graph, get slope y-intercept form. Well, y is already alone, so I'm ready to graph. I'm going to identify my y-intercept, which is going to be 0, 6, 1, 2, 3, 4, 5, 6. Excuse me. And then my slope is going to be negative 4, or negative 4 over 1. So I'm going to go down 1, 2, 3, 4, and then positive 1. And I'm going to go down 1, 2, 3, 4, positive 1. And so now I am ready to graph my line. 1, 2, 3, 4, 1. And there we go. Okay. There we are. Okay. Get the y alone. Going to get rid of that negative 3x first. I'll do that by adding 3x. I'm going to have negative 4y equals 3x minus 20. I'm going to divide by negative 4y, by negative 4. And that'll get me y equal to 3. There you go, negative 4x plus 5. My y-intercept is 5. 1, 2, 3, 4, 5. And my slope is rise 1, 2, 3, and then go back 1, 2, 3, 4. Okay, if I wanted to, I could have changed the signs and used a slope of negative 3 over positive 4. Going down 1, 2, 3, right 1, 2, 3, 4. And look at that, all 3 points are collinear. They end up being on the same line. So I'll draw my line like that. Extend it and stick an arrowhead on both ends. There's already one there, so I put one on the other end. Okay, so those are the solving ones. Oh, there's one more. Y is still alone. So my y-intercept, 0, negative 3. How do I know that the y-intercept is negative 3? There's no variable after the negative 3. There's no x. Remember, in y equals mx plus b, there's the y-intercept, and then there's the number next to x. Now you could think of your slope as 0, because this equation could be rewritten as y equals 0x minus 3. So I'm going to go 1, 2, 3, rise 0, run 1, rise 0, run 1. All right, so let's see here. Looks like I'm going to get a horizontal line. Now, if I were Mrs. Shopko, I would explain this a little bit differently. She would say, hey, give me one point where y is negative 3. And you might say 0, negative 3. So you're going to get this point right here. Then she'd say, give me another point where y is negative 3. And you might say 6, negative 3. And so she would go 1, 2, 3, 4, 5, 6, 1, 2, 3. And then she would say, give one more. And you might say negative 2, negative 3. And so you'd go back 2 and then down 3. And notice the 3 points that Mrs. Sopko would have had you find are different than the 3 points Mr. Lawrence had you find. 2 of them are different anyway, but they produce the same exact line. Both really good ways to think about the problem. All right, so one last problem I'm going to do, and you're going to need your worksheet in front of you for this to make sense, because I don't have the ability to copy this into what we're doing right now. My computer's acting funny. So I'm going to read the story, and I'll give you some of the information. And it'll say, Brendan joins the Jelly of the Month Club. In order to join the club, he had to pay a one-time fee and then he gets to purchase his jelly at a significantly lower price. The graph below shows how much Brendan spent for the number of jars of jelly that he bought. Well, I can copy this chart down. So we got our jars, the number of jars, and then we have the money spent. Okay, and so we had what, 10 jars, 15 jars, 20, 25, and 30. Okay, 10 jars, we did $60, then we did $85, and then we did $110, and then $135, and $160. All right, now you might want to find the points on the graph. It's hard to tell like exactly where they are, and that's why they give you the table. So on the graph that we have, I know for a fact there's a point right here that's at 10 for the x-coordinate, and the y-coordinate is at 60, just like in the chart says. I also know there's a point at 15, and the y-coordinate is at 85. Right? So what I'm going to do is I'm going to find the slope of this line. I'm going to see how much I rise and how much I run to move from one point to the other. Well, if you're paying attention in class, you see that we're going up 25. So my rise number is 25. Then you'll also see that I'm running 5. So I'm running 5. Well, that would mean my slope is 5. Well, since slope is going to be the price per jar of jelly, my slope is $5 per jar. Paid $5 a jar. Now, the y-intercept. that might be a little bit tricky. I know the line is going here like this, and on the graph, it's not going to look great on my picture, but on my graph we have like 20 here, and obviously this is 0. And this one sure looks like it's hitting smack in the middle if you're looking at your worksheet. Okay, something like that. And so I'm going to tell you right now, I want you to go ahead and assume that's 10. So that means my y-intercept is 10. All right, so I know my equation. My equation is going to be y equals 5x plus 10. Now question A says, how much did he pay to join the Jelly of the Month Club? Well, that's the y-intercepts. That'll be $10. That's the fee you had to pay to join. B says, what is the price of 1 jar of jelly? Well, if he joins the club, he pays $5 for each jar. Now, if you were paying attention in class today, you might want to answer this one as $15, right? Because he pays $10 to join the club, and if he only buys 1 jar, he's got to pay $5. So it's a $15 jar of jelly. That's pretty expensive. But if he buys lots and lots of jars of jelly, then it's not as big of a deal. All right. So question C says, write a linear equation. I already did that. There's my answer to C. And then use your equation to predict the amount of money Brennan will have spent if he purchases 55 jars. All I'm going to do is 5 times 55 and add 10. So let's see, 55 times 5, carry that 2, 25, 27, plus the 10, looks like it's going to be $285 for a total of 55 jars of jelly. By the way, if you take your calculator and divide 285 by 55, you can see what the price per jar comes out to be when you absorb that membership cost. Let's see, 5, 4, 5, I'm thinking, yeah. 275. Okay. So 55 will get me 450. So where are we at here? It's going to be a little bit more than 5, 6, 7, 8. Yeah, I think I like 8 there. I'm doing long division. That's all you can do it on your calculator. I'm going to get 4, 4. And then it's going to start over again at 100. And so I'm going to get 1. So I'm going to say about $5.18 per jar of jelly. Now this is a good deal if you're going to buy lots of jelly and if a jar of jelly costs more than, say, $5.25 in the grocery store. Okay, if you're not going to buy lots of jelly, it'd be silly to do this. You just go out to the grocery store. Anyway, there's going to be a problem like that on the test tomorrow that you're going to need to interpret. Remember that the slope is the same as the price per, and the y-intercept is the same as the starting cost or starting profit. All right, that's it. Mr. Lawrence signing off. Good luck on your test, everybody.